Hello students, welcome back. You might have heard about the destructive cyclones that hit Odisha, Andhra Pradesh and Karnataka several times. Thousands of people lost their lives and properties worth crores of rupees were destroyed. Cyclones affect agriculture, communication and electricity supply. In this video, let's learn more about cyclones and their formation. Before moving on to cyclone, let's learn some properties of air which will help us to understand the features of cyclone. Let's do an activity to understand how air exerts pressure. Take a tin can with a lid, fill it approximately half with water, heat the can on a candle flame till the water boils. Let the water boil for few minutes, blow out the candle, immediately put the lid tightly on the can. Now place the tin in a wash basin and pour fresh water over the tin. We can observe that the shape of the tin changes. Let's understand the reason behind it. We know that the tin is hot and inside it there is steam. But when we pour fresh water over it, some steam inside the tin can condense and turns into water. Then the amount of air inside the tin reduces and so is the air pressure. The air pressure outside the tin is more than that of the air pressure inside the tin. As a result, the air pushes the tin from the outside. This air pushes the tin from the outside and the shape of the tin gets distorted. When we fly a kite, the wind blowing from backside always helps us to fly the kite as the wind strikes on the kite and exerts some pressure. In our day-to-day life, we can find another example of air pressure. It is difficult to ride a bicycle in the opposite direction of the wind. This is because the wind exerts a pressure on the bicycle and on us in opposite direction. We need to overcome this air pressure in order to move forward. When air moves from one place to another, we call it wind. When the wind is blowing up to 20 km per hour, we can call it a breeze. It is slow wind. But when the wind flows at a speed of more than 100 km per hour, we can call it a storm. A storm is a strong wind. We have already learned about air pressure. Now let's understand how high-speed wind is accompanied by low air pressure. Take a small piece of paper and crumple it into a small ball. Hold an empty bottle on its side and place the paper ball inside the mouth of the bottle. Now try to blow the paper ball into the bottle. You will find it difficult to blow the paper ball into the bottle. Let's see the reason behind it. An empty bottle has always air inside it, and this air exerts pressure. When we blow over the mouth of the bottle, the air attains a greater speed and the air pressure in this area decreases. But the air pressure inside the bottle is higher than that of the air pressure outside the bottle. This air inside the bottle exerts pressure in the opposite direction. This will push the ball out. So if we want to blow the paper ball inside the bottle, we need to blow so hard as to overcome the pressure inside the bottle. From this experiment, we can conclude that high-speed wind is accompanied by low air pressure. You might have heard that high-speed winds can lift and blow away the weak roofings of buildings. Let me try to explain this on the basis of what we learned. The air pressure inside the roof is equal to the atmospheric pressure, right? But when the high-speed wind comes, the pressure above the roof decreases. Here the pressure is low. Air always moves from a high pressure area to a low pressure area. As the pressure under the roof is higher than that of the pressure over it, there is an upward push from the inside air. There is an upward push from the inside air on the roof. This push from inside the roof will help the high speed wind to lift the roof away. Let's now understand another property of air. It expands on heating. Let's do an activity to understand this. Take a boiling tube and stretch a balloon tightly over the neck of the tube and tape it. Take two beakers, one with hot water inside it and the other with cold water. Now place the boiling tube with the balloon inside the beaker with hot water. You can observe that the balloon is getting inflated. The reason is when we place the tube in hot water, the air inside the tube also gets hot. As it gets hot, the air expands. This expanded air needs more space to fit in. As a result, it rises and occupies inside the balloon. This will inflate the balloon. When the tube is placed in cold water, the hot air inside the tube also gets cooler and contract. The contracted air does not need much space and as a result the balloon deflates. Based on this observation, we can explain why smoke always rises. We know that the smoke contains hot air. As we learned, hot air expands and occupies more space. When the same quantity of air occupies more space, it becomes light. The expanded hot air is lighter than the heavy cold air. As a result, the light hot air rises. We learned that the movement of air from a high pressure area to a low pressure area is called wind. Let's understand more about the formation of wind. Wind currents are generated due to uneven heating on Earth. Let's examine two situations. One is uneven heating between the equator and the poles. Here you can see this is the equator and this is the north pole and this is the south pole. The regions close to the equator, this region gets maximum direct heat from the sun. In polar regions, the sunlight falls at a shallow angle which is spread out in a larger area and hence polar regions are cold. As the equator receives maximum sunlight, it heats up the air in that area. We learned that the hot air rises up. That means the hot air in the equator region rises. Here, the hot air from this region rises. Then, the cold air from 0 to 30 degrees latitude flows towards the equator. As the air from the equator rises, the cold air from 0 to 30 degree latitude flows towards the equator. And here is the hot air. This hot air rises. Then the cold air from 30 to 60 degrees latitude and north and south pole moves towards the equator. When hot air rises, the cold air rushes in to take its place. These arrows do not mean that the hot air moves down. For learning purposes, we draw like this as the earth is spherical. Like this, wind currents are formed due to the uneven heating on the earth. We have just now learned that the equator gets maximum heat from the sun. The land always warms up faster than the water. During summer, most of the time, the temperature of the land is higher than that of water. As a result, the air above the land gets heated up and expands. The expanded air moves up and thereby creates a low pressure area above the land. But there is high pressure over the ocean. Hence, the wind flows from high pressure area to low pressure areas. These are called monsoon winds. But during winter, the reverse happens. The land on the equator is cold most of the time during winter, and then the water above the ocean rises and form a low pressure area above the ocean. Then there will be low pressure area above the ocean and high pressure area above the land. Hence, the wind flows from land to ocean. During winter, the winds flows from land to ocean. The winds from the ocean, that is the monsoon winds, always carry water along with it. As a result, it rains. When wind comes from the ocean reaches the land, it rises with water vapors. These water vapors condense and form clouds, resulting in rain. Most of us enjoy the rain, and for proper functions of agricultural practices, we need rain. But sometimes the rain becomes dangerous. Let's learn two such situations: thunderstorms and cyclones. Thunderstorm is a weather disturbance for a short period of time which is always associated with lightning, thunder, dense clouds, heavy rain, or hail. Thunderstorms develop in hot and humid tropical areas. Tropics is a region of Earth by the equator. Due to high temperatures, air above the land rises along with water vapor. Air rises along with water vapor. When this water vapor reach high altitudes, they freeze and fall down. The water droplets fall down. This upward movement of hot air and downward movement of water droplets creates lightning and sound. Now we call this weather disturbance a thunderstorm. Now let's understand how a thunderstorm becomes a cyclone. We know that when water takes up heat, it becomes water vapor. Due to sunlight, the water becomes water vapor by absorbing the heat energy from the sunlight. This water vapor rises up along with hot air. Air plus water vapor rises up. At higher altitudes, this water vapor condenses and forms water droplets. Water vapor becomes water droplets or raindrops. At the time of this conversion, that is from water vapor to water droplets, it releases heat into the surroundings. It releases heat. This release of heat warms up the air surrounding it and the hot air moves up. As a result, there forms a low pressure area. During the conversion from water vapor into water droplets, heat is formed and this heat is released into the atmosphere. This release of heat warms up the air surrounding it and the hot air moves up. As a result, there forms a low pressure area. This is called the eye of a cyclone. As there is a low pressure area in the center, more air rushes into the center. This air rises due to heat released from the water droplets and more air comes in. This cycle is repeated. This cycle results in the formation of a low pressure center and high speed wind revolving around it. This is called a cyclone. Factors like wind speed, wind direction, temperature, and humidity contribute to the development of cyclones. Cyclones cause massive destruction. The wind is really strong, like around 200 kilometers per hour. This strong wind pushes the water towards the shore. We learned that the cyclone has a low pressure area in the center. As a result, the water surface is pushed to the center and the rising water may be up to 3 to 13 meters high. This rising water appears like a water wall moving towards the shore. This wall of water enters low-lying coastal areas and causes loss of life and severe destruction of property. It reduces the fertility of the soil as well. Continuous rainfall causes flood. High-speed wind can damage houses and communication systems. Now let's learn about tornadoes. Tornadoes are not frequent in India. Tornadoes are dark funnel shaped clouds that extend from the sky to the ground. A violent tornado can go up to a speed of 300 kilometers per hour. Tornadoes may form within cyclones. Let's learn about the safety measures during cyclone. A cyclone forecast and warning service is necessary. Rapid communication of warnings to the government and fishermen, ships, and to the public should be done. Construction of cyclone shelters in cyclone prone areas. The people living in cyclone prone areas should also take some safety measures. We should not ignore the warnings from the meteorological department. We should make arrangements to shift household goods, domestic animals, vehicles, etc. to safer places. Avoid driving on roads in standing water as flood may have damaged the roads. Keep ready the phone numbers of all emergency services like police and medical centers. Always drink safe drinking water. Do not touch wet switches and fallen power lines. Do not pressurize the rescue force by making undue demands. Cooperate and help your neighbors. Nowadays, we have advanced technologies that help to reduce the life lost by cyclones. A cyclone alert or cyclone watch is issued 48 hours in advance of any expected storm. Cyclone watches are alerts issued by national weather forecasting bodies to the coastal areas. A cyclone warning is issued 24 hours in advance. The message is broadcast every hour when a cyclone is near the coast. That's it about the chapter Windstorms and Cyclones. If you like this video, please share it with your friends. If you have any queries, put it in the comment box. Thank you.